prepared information for everyone's knowledge. Now you can watch the video presentation of Section 11A.
Good day, Chiefs! I am Don Carl M. Kagindagan, a proud Chief from STEM 11 11A. Also, I want to introduce to you my co-students, Joanna Panican, Kay Aguilar, Eliser Cuartero, Eros Zapanta, and Sofia Gabral, who will give us further knowledge about what we're going to discuss. Let me start the discussion first. We're going to discuss our main topic, which is all about the universe and solar system. First, what is universe? The cosmos is all existing matter and space taken as a whole. The universe is thought to be at least 10 billion light years across and contain an enormous numbers of galaxies. To add it, it has been expanding since its creation in the Big Bang Theory about 13 billion years ago. But wait, there's more. Here are some knowledgeable information about universe and solar system that you must watch. Joanna, take it away.
The formation of universe and solar system start in comets condensed in the outer solar system, and many of them are thrown out to great distances by close gravitational encounters with the giant planets. The Sun and the planets formed together 4.6 billion years ago from a cloud of gas and dust called the solar nebula. Size to time, scales of the solar system, the Earth revolves around the Sun at a distance of 150 million kilometers, 93 million miles. Hubble assisted astronomers in recognizing that we live in an expanding universe in which each galaxy is moving away from the others. If you read an introductory about galaxies or take an introductory class about them, you will most likely come across Hubble's law. In its most basic form, it states that the farther away the galaxy is, the fastest it is moving away from us. The concept is central to modern cosmology, which holds that the entire universe, space, time, and matter was created in a Big Bang.
Hi, my name is Eliser Cuartero from STEM 11A, and I will be giving some general knowledge by explaining this concept map. So this concept map talks about these spheres of the Earth. The spheres of the Earth all interact to form a complex system, which we call the Earth system, wherein there are 4 subsystems, also known as the spheres, which interact on or near the Earth's surface. The lithosphere consists of rocks and soil. Then, the hydrosphere consists of water in all forms. Next, the atmosphere is a layer of gases. And lastly, the biosphere, consisting of all the living things.
The idea received major boost from Edwin Hubble's observations that galaxies are speeding away from us in all directions, as well as the 1960s discoveries of cosmic microwave radiation, interpreted as the echoes of the Big Bang by Arno Penzias and Robert Wilson. Further work has helped clarify the Big Bang's theory tempo. Here's the theory. In the first 10 to 43 seconds of its existence, the universe was very compact, less than a million billion the size of a single atom. It's thought that such an incomprehensible dense gravity, electromagnetism, and strong and weak nuclear forces, but our current theories haven't yet figured out how a single unified force would work. To pull this out, we need to know the gravity works on the subatomic scale, but we currently don't. It's also thought that the extremely close quarters allow the universe's very first particles to mix, mingle, and settle into roughly the same temperature. In an unimaginably small fraction of a second, all that matter and energy expanded upward more or less evenly, with tiny variations provided by fluctuations at the quantum scale. That model of breakneck expansion, called inflation, may explain why the universe has such an even temperature distribution of matter after inflation. The universe continues to expand, but at a much slower rate. It's still unclear what exactly powered inflation is.
compare the different hypotheses explaining the origin of the solar system. This could have been caused by a passing star or supernova shockwaves. But the end outcome was a gravitational collapse at the cloud's center. Pockets of dust and gas began to gather in denser location as a result of the collapse. According to nebular hypothesis, according to this idea, our solar system's sun and all of its planets originated as a massive cloud of molecular gas and dust. In contrast, the large planets, Jupiter, Saturn, Uranus, and Neptune, fashioned past the factor among the orbits of Mars, Jupiter, wherein cloth is cool sufficient for unstable, icy compounds to stay stable. This hypothesis argues that the Sun, planets, and all other objects in the solar system formed billions of years ago from hazy stuff. Due to their better boiling point, simplest metals and silicates ought to exist in stable shape towards the Sun, and those might subsequently shape the terrestrial planets of Mercury, Venus, Earth, and Mars.
Hi, my name is Eliezer Joshua from STEM 11A, and I will be discussing and explaining how the geosphere, hydrosphere, biosphere, and the atmosphere are interconnected. So without further ado, let's begin our discussion. First things first, the geosphere. The geosphere, in turn, provides the platform for the ice melts and the water bodies to flow back into the oceans, while the atmosphere provides the geosphere with heat and energy for rock breakdown and erosion. The geosphere, in turn, reflects the sun's energy back into the atmosphere. Moreover, the biosphere receives heat, gases, and energy or sunlight from the atmosphere. It receives water from the hydrosphere and the living region from the geosphere. Hydrosphere falls from clouds in the atmosphere to the geosphere and forms streams and rivers that provide drinking water for the wildlife, humans, and as well as the water for the plant growth.
There we all have it, guys. That's great and informative shot for all of us. By the way, thank you to our co-chiefs for watching our video. We hope you learned something. Again, I am Don Carl M. Kagindagan from STEM 11, 11A. Mabuhay and happy Science Week!